This video showcases the Lamdauav FC405 stack. Lamdauav is a full-stack UAV company. We make automotive-grade flight controllers. We are here discussing about the FC405 flight controller. FC405FC is a complete solderless design. Means you don't have to haggle with the soldering. Complete plug and play. Features: STM32F405 microcontroller. IMU BMI 270. Barrow, DPS 368 better than DPS 310. Inbuilt OSD 5V at 3.5 ampere power. One of the lowest power supply current 80 mAh in idle stage, even low than your YLRS receiver.
So right now there
Supports
is no battery
bidirectional
connected.
shot. Shot
It has a
150/300/600.
gyro and a
Multi-shot
battery.
one shot.
The quad is angled here, so we will do uh, calibration, calibrate accelerometer. We'll go to the ports. So here, this FC405 has 6 UART ports. So on UART 3, I have the Express LRS diversity and RC connected, and on UART 6, we have the GPS, and the GPS baud rate is 115200, and this is the maximum baud rate, and this is configured into the GPS, and it gives you 10 hertz update rate. So you can see right now the battery is not connected, hence it is showing no battery. It is powered by USB. Quickly, I will showcase you three things. One is the motors. Another is the radio transmitter settings, and that's it. So mostly, let's jump directly into the motors. So this flight controller, we have enabled T-Shot 300, and it has a bidirectional D-Shot. I will showcase you the receiver settings. So right now, the Express LRS receiver is binded with the TX unit. So if you can see, I can do a roll pitch yaw throttle. So everything is responding here, and I have done a mode setting also. So if you go to the modes, so I have arming mode. So arm enable disable and one, but then I have angle mode set up over here. So angle mode will keep your FPV labeled, and you can enable disable it. And then I have enabled the GPS rescue. That is also on aux 3. Angle mode is on aux 2. And if you go down, then we have a flip over crash, and we have a beeper settings, which is, you can see, it's a momentary switch. So modes is all configured and working. Receiver, uh, we have showcased you that throttle, yaw, pitch, roll, everything is working and it is configured. And we have enabled the telemetry. So telemetry data also comes onto the Radio Master TX unit, and that's it. So GPS is also there. So right now, when I will power my quad with the battery, you can see the GPS searching will start. Let me power on the quad. So as soon as I power on the quad, you can see the battery detection is also there. And yes, I have a 3S 2500 milliamp LiPo battery connected here, and GPS is detected. So right now there is no locking of the satellite. Once the satellite is locked, uh, then you can see this thing will turn yellow, and on this area you will have all the details like 3D fix, number of satellites, altitude, speed, heading, everything, and here you will have a map also. So mostly this flight controller, I have been flying it for I think more than 2 months now, and these configurations work pretty much. Uh, and I have showcased you, right? It has 6 UART ports. On one of the ports, we have the Express LRS connected, and on UART 6, which is another port on which I have the GPS connected. And if you go to the configuration, so it's a typical BMI 270. So PID loop is configured accordingly. Here you don't have to do much of the changes. I have enabled GPS over here, and these are the standard configurations that comes with the stock Betaflight, and power and battery. Anyway, all these things are pre-fed into the configuration, so it gives you the usage, and you can see right now it's consuming around 0.75 amperes because everything is powered on right now from the battery. So whether it is flight controller, RC, GPS, and the ESC also has some standby current for each motor. So it goes close to zero point 0.5 ampere per motor, but looks like the motor and the ESC are decent, so the power consumption is less here. I have tested my flight controller in a standalone mode, takes only 80 milliamps of current draw, and if you connect the RC, and then the total current draw would jump to somewhere around 150 milliamps, because your Express LRS radio itself is a 100 milliwatt system, so it takes consumes somewhere around 100 milliamps, and that's it on the power side. And GPS would draw, as per the specs, it can draw up to 100 milliamps, but normally it would draw in the range of 30 to 50 milliamperes. So fail-safe settings, I have figured the fail-safe to stage 2. What it means is when I trigger a fail-safe button, which you can see in the modes, I have GPS rescue enabled here. So right now you can see GPS rescue is enabled. So I can disable it. I can enable it. So when the GPS rescue will be enabled, this fail-safe mechanism will trigger to stage 2, and it will start following the GPS rescue mechanism. This thing needs to be tested out right now. Uh, so when I'm going to fly next time, so this thing will be tested. So I'm going to do a save and reboot here. The motors are all working fine. If save and reboot here also, go back to motors and see. So right now what I will do is showcase you the bidirectional D-shot capability. So I'm going to do a motor test, and before you do, remove your props, and then I'm going to slowly increase the throttle of the master. So now at this point of time, all the motors are spinning. But what is more important to see here is this data. This is the RPM data for all the motors that is coming in, and this is the temperature and what is the error rate that is being reported right now. So bidirectional D-shot is a major jump in technology. Earlier, we used to have a telemetry wire that would come from the ESC, where the data would come. But now, if your flight controller supports bidirectional D-shot as well as your ESC, then you will be receiving all the motor data on the same four motor wires on which your flight controller is sending the data. So it's basically a bidirectional communication that is happening between your motor as well as between your ESC and your flight controller. So flight controllers keep on sending the D-shot signal. Okay, this is the throttle uh, mm, data, and ESC also sends back on the same motor wires. Okay, what is the motor RPM and all of that, and that helps the Betaflight or the firmware which is running on the flight controller to understand. Okay, at these levels of motor spinning, this is my current IMU heading, my GPS heading. So what should be I doing next to respond to the either to the user input or to level out. To stop the motors. So here all the motors I have pre-configured, so they are all spinning in a proper direction. I have done quite a few tests also uh, on this, and uh, I have flown this quad at least I would say 50 to 60 hours so far on the same motors, same every setting, and you know, we have not found any glitches. So I'm going to stop the motors now, because today I am going to test the GPS and GPS rescue mechanism. So GPS is the new module that we have developed, and we have got a 3D fix and lock also. uh, Last time I checked, I got 15 satellites locked on and 3D fix. So after tuning this quad a bit more, I'm going to test the GPS rescue. And this GPS is a dual band GPS, and it is capable of IRNSS. IRNSS means Indian Regional Navigational Satellite System, also known as NAVIC. So this GPS module that we have developed, uh, there will be more details coming out soon. But yeah, it's basically a Navic GPS with a dual band capability and has a DGPS capability also. So let me test out how well the GPS rescue works, and then in the next video I can show you those details.